Welcome to Brain Vision.
Problem 11.81. We have a 12 kilogram mass that's fastened to the end of an aluminum wire whose unstretched length is 0.7 meters. And then we spin this around at 120 RPM. The cross-sectional area of the wire is this. And we want to find what the elongation in the wire is at the lowest and highest points of the mass in the path that it goes along. So at the lowest point, we're going to have the tension going up and mg going down. Centripetal acceleration is going to be pointing upward. And so the tension minus the weight has to be equal to m times the centripetal acceleration, which is r omega squared. Now, in order to actually get the right numbers, everything has to be in the right units. That's a fact of life. And this is not the right units for omega. Omega should be in radians per second. And it transpires that 120 RPM is 12.57 radians per second. So the tension is going to be m times g plus r omega squared and this is 1,445 newtons. So now we use the stress-strain relationship. We find that elongation is equal to the tension times the unstretched length divided by the Young's modulus and the cross-sectional area. You can look up the Young's modulus for aluminum in the table at the beginning, or toward the beginning of, or somewhere in the chapter. It would not be at the beginning. Anyway, and so you find doing this that the elongation is going to be 1 centimeter. Now here, both the weight and the tension are downward. One of them is, this may not be the correct, tension might be smaller than the weight. We don't know yet. But what we do know is that the centripetal acceleration must be pointing downward. And so here we'll find that the tension doing the same thing as here, just with, there's a plus sign. So the tension is going to be the mass times r omega squared minus g. So this is 1,210 newtons. And then plugging this into our equation up here, we find that the wire is stretching by 0.86 centimeters.